Hello, everybody. Can you hear me all right? Yes. Thank you for being at this session today. My name is Yulia, and today I'm going to tell you about how to build trustworthy AI products with regard to navigating bias and fairness. And I will give you a few examples from the media and news industry. So, first of all, when I was thinking about the session, I was wondering how can we use this 20 minutes that we have here today together in the most engaging, interesting, and informative way. So here's what I suggest. First of all, I will tell you about why this is important, and then about how. And I will give you a couple of hacks that you can use in your companies, in your applications, how to deal with bias and fairness. To begin with, I wanted to have a look at the diagram on your screens. I hope you can see it, but I can also walk you through it. I looked at all ML and AI innovations that happened in the past 15 years. And I would like you to think about it in terms of 3 different phases. The first phase happened between roughly 2010 and 2017. And that's the so-called era of deep learning, when GPU acceleration helped us to build advanced deep learning models in computer vision, in natural language processing. And that's the term deep neural networks has kind of emerged. And during the same phase, you probably have heard about things like AlphaGo, the reinforcement algorithm that was able to beat world champions in Go game. And also probably have heard about generative models like adversarial networks that could create deepfakes. So that has been developing in the course of about 7 years until we reached the milestone of roughly 2017. That's the first phase. In the next phase, between 2017 and 2022, so what happened is that lots of, I would call it the cloud era. It's a time when lots of companies started to work on the cloud. They either became multi-cloud, a hybrid cloud, and lots of the vendors like Google, Microsoft, AWS were enabling API services, create API layers that could enable companies, including companies in media and news industry, to leverage developments in deep learning and integrate them smoothly into their workflows. And what has been happening around 2017, maybe some of you know, is that the transformer architecture has emerged for the first time. And it's a really brilliant architecture that allows to introduce attention into the neural network. So it's able to look at different parts of sequential data at the same time, no matter how far it is from each other. So during the course of about 4.5, 5 years, transformer architecture has been developing. And then what happened is 2022. And we all know what happened then. ChatGPT has happened, right? And what has been happening prior to that time is advancements in reinforcement learning, advancements in transformer architecture. Those are the key elements of generative models that we have today. What happens now, I would call it we are in the era of generative AI. And in the past 2.5 years, we have observed tremendous growth of generative models. And not only there is abundance of different options, different vendors, different open source models, but also the complexity of these models have grown tremendously. GPT-2 model only has 1.5 billion parameters. GPT-3 has 175 billion parameters. And we don't know how many parameters is there in GPT-4 and alike models, right? So the key takeaway from this slide is that the pace is accelerating exponentially, complexity accelerating exponentially, and having this much innovation that happened in the past few years could not gone in a way that it wouldn't be transformational for many industries. It's definitely causing disruption. It's definitely causing change. It's definitely causing us all to rethink how we how we build our products and how we build our connection and our relationship with the audience and with our customers. The next one, please. Okay, one more down. Yeah, thank you. So when we adopt AI technology, we are also we also need to think about what kind of opportunities and what kind of risks it introduces. And nowadays, AI risks are not just independent from everything else. AI risk actually proliferate into reputational risk, financial risk, operational risk, ethical risks, and so on. So there is many dimensions that you have to think about when you build an AI product. And speaking about news organization, I think it's also very important, specifically when you think about ethics and you think about the impact that you create. And it's really important that news are focusing on integrity, independence, freedom, and how to ensure fairness when it adopts AI. Next. I'll take a minute and I'll just explain what AI risk essentially is. So in the 90s, most of the algorithms were rule-based. It means that if you observe X, then the output will be A. When the data is very complex and you don't know or you cannot build direct mapping between incoming and outgoing data, you are in a situation when you're likely to use machine learning algorithm. And what you need to remember that these algorithms are inherently probabilistic, which means that there's probability assigned to the outcome that they predict. And what can happen, even if your algorithm is 99.99% accurate, there will be 0.001 chance that it will make some mistake. And it's really important to evaluate and test your algorithms on very rigorous data sets. And I'll take a pause here and I'll give you a small example. Quite a few years ago, with one of my work partners, we built an experiment on analyzing, for marketing purposes, recognizing faces of sport athletes who play soccer. I don't know if there's any soccer fans in this audience today. Okay, we have some. And the algorithm was extremely accurate. I think it was like 99 point something. And of course, he found some false positive examples, and we decided to explore them. So one of the examples was that one of the young men was misclassified or mislabeled as a 16th century Japanese warlord. Where would that come from? We didn't know. So we really wanted to understand, and to be able to explain mistakes that happen of that kind. So explainability is the first thing. The second example was also very funny. One of the young athletes was mislabeled as somebody else. And I researched what was the actual real name and what happened. And what happened was that there's two twin brothers playing at the same time in the same league for two different clubs. I wouldn't be able to tell which of them is which one. They are identical. And so AI algorithm wasn't also able to tell which of them is which one. And the only way how you can actually do this is by being a subject matter expert and knowing which of them is playing for which team and which game happens at which time. So that's another example. So what is important for us to remember is when we introduce AI into our workflows and into our processes, is to introduce a monitoring plan in the same way how you do it for any other software. And what you need to remember to include into this is that you have to test your model for various attributes and to be able to receive alerts when something is going out of hand. Particularly, you want to test the model for data and concept drift. You want to analyze if there's any bias in your model, and if possible also to add explainability, to explain the logic or to understand what can go wrong. Secondly, it's really important to agree within your team, with your key stakeholders, on the matter of what will be the acceptable range of potential mistakes that can happen. So what will be the risks and what kind of risks your company can handle if they happen, and to mitigate them and to minimize them as much as possible. And when you do this, you also set a set of alerts that will trigger, that will be triggered if the performance of your model goes out of those ranges. So let's now move into specific examples of bias in news and media. The bias definition is different depending which expert you're asking. I think even if you ask yourselves, how do I think about bias, there will be probably different opinions in this room. So if you ask a person from editorial perspective, what is bias for them, they will tell you that bias is first and foremost as a prejudice towards some groups or some individuals. If you ask an ML specialist what is bias for them, they will tell you that in ML, it's an ability of machine learning algorithm to capture the true relationship in the data. And bias is important to navigate and to mitigate because the consequences of that can be really severe. It can lead to public embarrassments. It could lead to legal ramifications. So when you build trustworthy products, you really need to understand those possible risks. And in the next slides, we're going to specifically focus on editorially defined bias. So, for example, let's talk about transcription. So imagine that you are a broadcaster or a news provider or media company, and you would like to create a service or to add a service that transcribes some media or newsworthy events. Let's say a G7 summit. And there you're likely to expect that all participants will be able to speak English to discuss some important matters, but people will come from all over the world. They will come from different ethnical backgrounds. They will all have also their mannerism and accents when they speak. And what comes with that is that when you evaluate your system, which you hopefully do, for accuracy, you also not only look at the overall performance, but you also look into how does the system perform with regard to different ethnical and geographical groups. For instance, if you have a system that's 97% accurate, but 3% of the errors happen with regard to certain ethnical group, it's not good. So what I would like to introduce you to think about is that in this specific case, you can think, okay, I want to test how does my system perform on native speakers and non-native speakers. Will there be any difference? The other dimensions you can look at is gender, like male, female, maybe age, and so on. How do you normally measure accuracy or performance? Okay, performance of your ML system. You need to have something that's called ground truth. In this case, it will be what editorial created over the years in terms of transcribing events. And you will need to compare it against transcriptions created by AI system. And you apply some metric of your choice. Here I gave you a few. Liebenstein distance, Roux score, Jacquard distance, Kazan similarity, whichever you choose. Choose any, choose all of them. And you look at the distribution of performance between those two different those two groups, and the further distribution is from each other, the more likely you are to observe the bias when you go live in production. Here comes Kivit. As a news and media organization, what you're likely to see in the data that they produce, they would say, okay, the former Prime Minister Sanna Marin is attending the summit and she's saying this, this, and that. So news and media organizations will not capture or will not store any information about gender, race, because first of all, they don't need it. Secondly, I think it's rather unethical. So it will be only factual about actual events and people who are taking key roles in those events. But in order to be able to analyze potential bias, you need to find a hack. How are you going to create this data, all these labels? Of course, you can ask your editorial. And I can tell you, people at the editorial are very busy people. They're very, very busy. So they will not have time to go through hundreds of thousands of scripts and label those people for you. So you need to come up with a hack. And one thing you can do here as a news and media, possibly global organization, is to look for different ways how you can create these labels. For instance, you can use, you can look up these individuals, let's say on Wikipedia, and extract information about them, who they are, which country they represent. And of course, this is not going to be a 100% accurate source. You still will need to engage with subject matter experts. So we will talk more about this later, but you will really need to engage with them so they can verify ML labels that are produced like this. So as I promised, here we go, the technical slide. So specifically for the purpose of this session, I created an example what you can do. So I took an open source data set from Mozilla. It's called the Common Voice data set. And I created a distribution for us here for native and non-native speakers to demonstrate how distribution of quality metric of performance metric will look for two groups, for native and non-native speakers. So if you see something like this, when you do your analysis and you see, all right, it's likely that there is no big difference between how my tools will work for different social demographic groups. So your service is not prone to bias. If you can observe something like this, that's great. Of course, there will be differences, and of course, there will be some errors the system is making. And in that case, it will be really important that your team will go back to those examples and understand when and why they happen. Maybe they happen because there was some summary or some shortening of the actual speeches done by the editors. It's possible because people, when we talk, we add some, words like maybe we repeat some words. So of course, editors will clean that for their consumers. So that can happen. Sometimes labels can be inaccurate. Sometimes they can be honest mistakes by the AI algorithms. So it's possible to go back and actually investigate what happens. Okay. So another example that I would like to give here is not on the is now on computer vision domain, and specifically how public personas could be identified or identified and labeled in the news content. The very same thing. What we're likely to experience or we're likely to observe, and it's likely to be, we need to be aware of that many computer vision or facial recognition techniques are prone to bias. Especially they're prone to bias with regard to nationality, ethnicity, and gender. If you open Google Scholar today and you type in you type the publications on facial recognition bias with regard to race and age or something like that, you will likely to see over 1 million publications on the subject. So it's a very, very important topic. And it's really important that if this is something that you want to integrate into your process, you need to address that. In the very similar way as you would approach transcription and bias in transcription, you can approach the bias in identifying public personas. You are likely to, if you're likely to observe some errors, you need to analyze where they come from and consult with subject matter experts on that. And also, because there's multiple metrics you can look at and you can implement in your analysis, focus on precision. Precision is something that works on false positives, and because it's always worse to mislabel a person as somebody else than not label at all. So when you do that, and when you are able to create a set that you can verify your model on subject of race, ethnicity, or gender, apply the similar technique and look at distribution of your results over those two groups. Thank you. So I'm going to close up this talk. Here is my QR code for my LinkedIn. I know we might not have time for questions right now, but I'm happy to take any of your questions later during the break, or feel free to connect with me on LinkedIn. And I'll be happy to discuss with you how to build trustworthy AI solutions and talk about AI. Thank you.